Hi, let us continue with our discussions about curtailments of reinforcement in simply supported beam using the simplified curtailment rules as demonstrated in the diagram here. So far, we have gone through 3 examples demonstrating various scenarios, how you can make use of the simplified rules for the curtailments of the reinforcement. Due to the other considerations, including the minimum bar spacing, symmetrical arrangements of the reinforcement, minimum numbers of reinforcement in a beam section, the curtailments of the reinforcement cannot be simply taken as 50% reductions of the amount of reinforcement bar without adjustment. Under some circumstances, no curtailment is required, whereas under some circumstances, the amount of reinforcement bar after curtailment may not be exactly 50%. In this video, we're going to do a quick review based on the example that we did in our previous videos. All the 3 examples that we did are simply supported beam. That means these curtailment rules apply on the basis that the loading is the uniformly distributed load. Based on the rules, you will have 100% reinforcement bar at the midspan and 50% reinforcement near to the support. And then the reinforcement may be curtailed at a distance from the support of 0.8 times the effective length, which is rounded to the nearest 25 mm for easy conversions between SI unit and imperial units, with 25 mm equals to 1 inch. By multiplying this 0.08 times the effective length, if the number is not rounded to the nearest 25 mm, you will need to round down the number, allowing a longer span of this 100% reinforcement without compromising the simplified rules for the curtailment. That's why in the first example, when the effective length is 3.5 meter, 0.08 times 3.5 meters is equals to 280 mm. You should round down to 275 mm instead of rounding up to 300 mm. This will lead to you providing slightly more reinforcement as compared to what is stipulated by the simplified rules. And then about the 50% reductions of the reinforcement near to the support, it is very much dependent on the numbers of reinforcement bar provided. Before that, you will need to determine the proper layout of the reinforcement, which is by taking into considerations of the minimum spacing of the reinforcement so that concrete can flow through the reinforcement during casting, ensuring a good bond conditions with the reinforcement. You will need to arrange the reinforcement bar in such a way that the spacing between the reinforcement needs to be at least greater than the minimum spacing. The top priority is normally given to the layout, which can give you the maximum effective depth, as we would like to capitalize the increased effective depth for a greater moment resistance of the section. In the case that the spacing between the reinforcement bar does not meet the requirement, then you can consider stacking the reinforcement. As a result of stacking the reinforcement, the effective depth it will be calculated on basis of the centroid of the reinforcement group, which will be slightly less than when it is laid in one single layer. Once you have concluded the layout of the reinforcement, you will need to arrange the reinforcement in a symmetrical manner, such as something like this, or this, or this, and etc. And then, based on the 50% reductions, for the first example, it is easy. You can curtail these 2 reinforcements reducing a total of 4 reinforcement bars, make them into 2 reinforcement bars near to the support. This is just nicely 50% of the main reinforcement bar at the midspan. In the case of the example 2, you have odd numbers of reinforcement. Due to insufficient clear spacing between the reinforcement, steel bar needs to be stacked together, leaving 3 reinforcement bar in the first layer and another 2 reinforcement bar in the second layer. The effective depth will be calculated on the basis of the centroid of the reinforcement bar group. And then near to the support, curtailment can be done in such a way that the remaining bar needs to be at least greater than 50%. Therefore, in this case, you can only curtail 2 reinforcement bar, leaving 60% of the reinforcement bar at the support. You cannot curtail the 3rd reinforcement bar here, as this will lead to only 40% at the support, which does not fulfill the requirements of the simplified rules of the curtailment. Example 3 that we discussed previously show another scenario where you only have 2 units of reinforcement bar at the midspan. Although the curtailment rules allow you to reduce to 50%, you cannot simply curtail either one of the reinforcement, as the industrial practice will require at least 2 units of reinforcement bar at the bottom and another 2 units of the reinforcement bar at the top. The purpose is for the workers to tie the shear link with the reinforcement. There is also requirements that the size of the reinforcement cannot be less than 12 mm diameter. Because of the constraint of the minimum numbers of reinforcement, this curtailment rule cannot be applied. As a result, you will maintain that 2 units of reinforcement bar throughout the entire beam span, leaving you the amount of reinforcement bar at the support same as the midspan. Also bear in mind that when we talk about simply supported beam, normally we refer to the bottom reinforcement bar as the tension bar. The solutions after the curtailments are indicated here, which in the actual case, you will still need to put an additional 2 units of the reinforcement bar as the top bar, with the diameters of at least 12 mm, even though it is not required in the beam. Especially when you do the moment resistant design, the beam indicated to be simply reinforced and no compression bar is required. At least 2 units of 12 mm diameter steel bar are required as the top bar. It is with the purpose to tie with the shear link. You need something to hold the shear link in the position. Therefore, in normal practice, when the calculations indicate that no top reinforcement bar is required as the compression bar in simply supported beam, you still need to provide at least 2 units of steel bar with dimensions of 12 mm diameter.